Now, let's dive in to creating a new Swift file to encapsulate distinct functionality within our app. So, the code we're working with defines a class named newClass, which acts as a blueprint for crafting objects that will showcase specific behaviors and properties. Inside this class, we've got a method named sayHello. Now, here's the cool part. When we invoke this method, it simply prints a cheerful greeting message to the console. This structure lays the groundwork for object-oriented programming in Swift, which means we can create instances of newClass that encapsulate more complex behaviors as needed. By organizing our code this way, we're not just making it functional, we're also enhancing its readability and maintainability, especially as our projects become more intricate. Think of it as building blocks. Each class can represent different functionalities or features of your app, making it much easier to manage and develop over time. Such a modular design helps keep your code organized, allowing for the reuse of classes across various sections of your application. Now, as you're building your iOS app, I really encourage you to consider creating classes for different aspects of functionality so your code base remains clean and efficient. Such a modular design helps keep your code organized, allowing for the reuse of classes across various sections of your application. Now, as you're building your iOS app, I really encourage you to consider creating classes for different aspects of functionality so your codebase remains clean and efficient. Now, let's see how we can implement image loading in our app using Swift. So, we're going to explore a handy code snippet that demonstrates a common pattern for safely loading an image from your app's resources. It all begins with something called optional binding. This is where we attempt to retrieve an image named logo.png using the UIImage class method named. What this method does is search for the specified image in the app's resource bundle. Now, if the image is successfully found, we safely unwrap it. That means the image variable will hold a valid UIImage object. We then assign this image to an UIView app, which we'll call ImageView. This process is really important because it ensures that our app only tries to set the image if it actually exists, which helps to prevent potential crashes that could occur from trying to use a nil value. By organizing your images in the Resources folder and loading them programmatically like this, you're not just keeping things tidy, you're promoting a clear structure in your project. This, in turn, enhances the user interface of your app with seamlessly integrated assets. It's a fundamental practice in iOS development, ensuring that your app runs smoothly and interacts pleasantly with users. Now, what we see here is quite telling. Code and asset management really take the lead. Source and resources together make up a whopping 55% of the distribution, emphasizing that more than half of the project's focus is on organizing and maintaining those source files and assets. The project navigator, sitting at 20%, plays a crucial role in providing access and organization across our code and those resources. On the other hand, we have info.plist at 15%, which represents a significant yet smaller part dedicated to application configuration and metadata. This highlights that while configuration is essential, it's not the mainstay of our daily project activities. And finally, the debug area, which at just 10% is the smallest segment on the chart, suggests that although debugging and runtime inspections are incredibly important tasks, they occupy a lesser portion in our project's perceived structure. So, from this distribution, we can conclude that prioritizing a clear organization of our source code and resource files should be our primary focus, while also managing our info.plist entries carefully. And let's not forget to leverage the project navigator and debug area effectively for a smooth development experience and easier troubleshooting. Now, let's implement the necessary entry in the info.plist file to request camera access from users. This is essential for any app that needs to utilize the device's camera, as it allows you to communicate the purpose of this access to the user. The specific key to include is NS Camera Usage Description, which serves as a flag for the system to understand why your application is seeking permission to use the camera. So, in our entry, we'll pair this key with a corresponding string value that explains to the user about the camera's usage. For example, you might say, "This app requires access to your camera to take photos." This message pops up when users are prompted to grant this permission, ensuring transparency and building trust. It's really imperative to present a clear and concise reason for this access. Failing to do so could actually lead to your app being denied during the app review process. So remember to craft this message thoughtfully, as it plays a critical role in user experience and your compliance with App Store guidelines. As your project scales, source control becomes an essential tool for tracking changes and collaborating with others. Now, Xcode comes equipped with some nifty source control features that are integrated with Git, which means you can manage your project versions right from the interface. You can find this under the Source Control menu, where you can easily commit changes, push to repositories, and manage branches. Now, let's take a look at the Source Control Preference screen. This is where you can configure your repository settings, like defining remote repositories or adjusting your sync and commit preferences. Check out how it can look. In this screen, you can connect your project to a Git repository, allowing you to push your local changes and ensure that collaborative work stays in sync. And here's the best part. Having this capability integrated into Xcode means you can focus more on coding and less on managing your project outside of the IDE. So let's embrace this tool and streamline our workflow. Navigating back to your project, let's explore how to utilize additional features like groups to organize your files better. Now, Xcode does a decent job of auto-organizing files in the navigator based on their type, but here's the cool part. You can create custom groups to sort things out according to functionality or features. For example, imagine you're working on, let's say, networking tasks. You might create a group called Network where you can stash all your networking-related files, like your API clients and models, all in one place. To make a new group, simply right-click within the Project Navigator, select New Group, and then drag existing files right into that group. Keeping related files together, that's going to make for quick access and really boost your workflow efficiency, especially in larger projects. Finding files quickly, right? So, let's say you're deep into network calls. You could have your API manager.swift, network era.swift, and models such as user.swift all tidily organized in the network group. That way, making changes to your networking logic becomes as easy as pie. And who doesn't love that? Now, let's implement a basic button action that responds to user interaction. In the code, we define a function using the @IBAction keyword, which signifies that this function is designed to be called in response to a user action. In this case, that's tapping a button. The function is named button_tapped, and it takes one parameter, _sender UT_button. This parameter refers to the button that triggered the action, allowing you to access its properties if needed. Inside the function, we have a simple statement that prints a message to the console: "Button was tapped." This serves as a confirmation that the button press was successfully registered. Using print statements during development is an excellent way to track the flow of your app and debug issues effectively. Now, in the context of the storyboard you created earlier, linking this code to the button ensures that whenever a user taps that button, this function is executed, allowing your app to interact responsively with user commands. This really demonstrates how storyboards can simplify connecting UI elements to the underlying code logic, making the app development process not just more intuitive, but also more visual. Now, let's take a look at how we can implement a function to handle user input when a button is tapped. In this code, we define an action method called submitForm, and this is linked to a button in our user interface. So this method will be triggered whenever that button is pressed. Inside the function, we begin by retrieving the text that's entered in two text fields, username field and password field. This gives us access to the user's username and password, which are, crucial for login functionality. The values entered by the user are stored in constants for further processing. Next, we print a message to the console displaying the submitted username while keeping the password hidden, of course, for security reasons. This logging step is vital for developers to debug and ensure that the correct username is being captured without exposing sensitive information. In a real application, you might follow this action with authentication logic, like validating the input against a database. Overall, this simplicity in handling user input highlights the importance of maintaining security protocols, particularly when dealing with sensitive user data, like passwords. In summary, understanding the Xcode project structure is crucial for effective iOS development. From navigating the project navigator to leveraging source control and utilizing storyboards, every aspect plays a role in streamlining the development process and enhancing your coding experience. So, as you continue your journey into iOS development, remember to periodically revisit your project structure and keep it organized. This will not only help you maintain clarity in your coding style, but it will also enable more efficient collaboration with other developers along the way. Now, in our next session, we're going to dive deeper into control flow statements, exploring conditionals, loops, and how they help in making our applications dynamic and responsive. The journey continues, and it's only getting more exciting from here.